Caught in time-lapse, the closest planet to the Sun, in transit across the Sun. Baked little Mercury, on the inside track. To understand Mercury, we return to the early solar system. A disk of gas and dust rotates around the newly fired-up Sun. Hot and dense at the center, farther out the disk is diffuse and cool. Close to the Sun, tiny particles condense, heavy materials with a high melting point. Beyond, grains are lighter and icy. Particles begin to clump. And the great disk starts marshalling into rings. Everywhere, collision and aggregation. Grains grow as big as basketballs, houses, mountains. And as they grow, so does their gravitational pull, offsetting the tug of the Sun. Rings in the disk are increasingly defined, and within them, mini-planets are forming, so-called planetesimals, constantly growing as they sweep up debris. But it's still a mayhem of impact and assimilation. The bigger the body, the stronger its gravitational pull, and the more it grows. Thus do the planets shake out. In the farthest reaches, great spheres of gas riding vast and lonely orbits, but closest to the Sun, solid little planets. Debris remaining between the orbits is blown away by the solar wind. The veil is lifted on this empire of the Sun. And the Sun still rules some 5 billion years later, with dense little Mercury the closest subject. Mercury, Venus, Earth and Mars are the rocky inner planets, the terrestrials, where the heaviest elements condensed. Jupiter and its fellow giants are balls of gas. They condensed in these cold outer regions from lighter elements. With the Sun just 58 million kilometers away, Mercury is scorched and irradiated as no other planet. It's named after the messenger of the gods, and why not? For the ancients saw the Sun as a god. Mercury is the smallest inner planet. Earth is 18 times as massive. Compare their diameters. Mercury is less than 4,900 kilometers. Earth is over 12,700. And they've different attitudes. Earth tilts. Mercury doesn't. Twilight on Earth, with Mercury on the right and Venus above. As they move through their orbits, they're never high in our sky. Mercury is the most difficult to see, barely clearing the horizon at dusk and dawn. A change of perspective shows why. From Earth, we see only part of their tight solar orbits. Venus, the outermost, orbits in 225 days. Mercury in 88. Mercury crossing the Sun. Such transits occur 13 or 14 times a century. We see them because Mercury, just like Venus, lies between us and the Sun. (1973). Blast off for Mercury. The mission is Mariner 10. Using the pull of Venus as a push towards Mercury, the craft was the first to use gravity assist, now a common technique. 2 months later, Mariner skimmed Mercury at just over 700 kilometers. There were 3 such flybys. They yielded a photographic feast. Here was a pristine record of the early solar system, the whacks and smacks that cratered this barren little world. Upper right is the Zola crater, remnant of an impact so mighty that ejected material dug these mini-craters. These craters could be in the highlands of our moon, another lifeless desert. From upper left come the streaks of a ray crater, the imprint of an impact on older terrain. Mercury has basins and less cratered regions like this. They indicate a younger surface, formed in a volcanic epoch when lava flowed. Great cracks betray a crust that has cooled and shrunk. Mercury has a mind-boggling calendar. Its day, sunrise to sunrise, is twice as long as its year. See how slowly Mercury spins as it circles the Sun. Watch the arrow. In a single orbit, the planet turns only 1.5 times. Earth, by contrast, would spin 365 times. The result is that Mercury's day lasts 176 Earth days. Mercury's year is just 88 Earth days. And it becomes stranger. From the surface of Mercury, during its long, long day, the Sun shrinks in the sky. Nothing to do with the Sun, all to do with the planet's varying distance from the Sun. Mercury has an elliptical orbit, and it produces an even weirder effect. Each time it passes close to the Sun, Mercury speeds up and slows again. The consequence on the planet is a double sunrise. And it happens only when Mercury is closest to the Sun. Early in its history, Mercury may have been struck by a large planetesimal. Such an impact could have blown off the planet's outer mantle. That would explain, relative to its size, Mercury's huge iron core. It's 70% of volume, twice the proportion found in other terrestrial planets. There's no doubting the impact that happened here. With rings of mountains curving towards the left, this is one side of the huge Caloris Basin. The cause was another planetesimal. 4 billion years ago, it gouged a crater 1,300 kilometers wide. Splattered later with these smaller craters, the basin had probably filled with lava. The mountainous rim of Caloris, lava fields to either side. Volcanic activity lasted 1 billion years, but for the past 3 billion, it's been quiet. Lava plains surrounding the Caloris Basin. Caloris means heat, well named, for the basin can be Mercury's hottest spot, with a daytime peak of 450 degrees Celsius. At night, temperatures plunge to -180. And radar mapping suggests permanent ice on Mercury. Radio telescopes in the United States and here in Puerto Rico hint at the paradox. If it's true, ice could only survive on Mercury in deep craters at the poles. There, perpetually shadowed from the Sun, could be the icy deposits of comets. Most of our knowledge of Mercury is from Mariner 10 in the mid-70s, and that left more than half the planet, the blank areas, still to be photographed. But new missions are planned. This is Bepi Colombo, a probe to be launched by the European Space Agency. Like Mariner, it will slingshot via Venus. So much is to be gleaned from Mercury, with its wispy atmosphere of helium and a surprisingly strong magnetic field. The Americans plan flybys with this messenger craft to better know what shaped this planet. Mercury's surface is the history of our solar system from the earliest times.